you have a lot of issues.
Yes.
I want to, because I heard it's really good people on there.
That's all it does. Let me get
Step one, do stuff.
Wait, it's autographed.
Because I have a watch on, and when I put it on, it automatically. The library? Yeah, you told me so.
There's a model called collision theory. It's used to relate the properties of particles to the rates of chemical reactions. According to this theory, atoms, ions, and molecules can react to form products when they collide if the particles have enough kinetic energy. So this is the key term, kinetic energy, associated, Cody, with collision theory. So when you hear about collision theory, it's really all about kinetic energy. Kinetic energy could be associated with activation energy, and then what else? 5 points. What other energy could be given off in the reaction? That would be like exothermic energy. Right, so when our reactions occur, they can release energy, that would be exothermic, or they can continue to absorb energy, that would be endothermic. Now if it's endothermic, your collisions are going to be fewer because you don't have the kinetic energy for the collisions to occur. It says particles that do not have enough energy to react bounce apart unchanged when they collide. So then you wouldn't have any products form because you didn't have enough energy. Does that make sense?
Equation called a rate law. A rates law expresses the relationship between the rate of a chemical reaction and the concentration of reactant. For example, the reaction A yields B is a one-step reaction.
Rate given like this had to be experimentally determined because they are telling you the order of the H2O2. They're telling you that it is first order. There's a 1 there. So they're telling you that it is a first order. So what does that mean that the rate there is first order? Remember from yesterday? I told you that yesterday. If it's a first order reaction, the rate is dependent upon the concentration. So if your concentration changes, your rate changes. It's directly dependent. There's no doubling, there's no tripling. It's a direct relationship. First order is a direct relationship. It's like a 1-to-1. This goes up, that goes up. That's first order. Zero order, what is that? Zero order, there's no change. So if I increase the concentration, doesn't matter by how much, the rate does not change. So you can increase the concentration, the maximum concentration possible, the minimum concentration possible, the rate is not going to change. That's called zero order. So zero order and first order are the two most important to understand as far as what's going on. Okay, zero order, no change. First order, increase the concentration, the rate increases by the same amount. It's a direct relationship. Does everybody see that? Any question there? Pretty simple.
Chemical reactions, particularly those that have more than one reactant, are not first order. Consider the general form for a chemical reaction with two reactants.
NO to the second power H2. So can anybody tell me what is the overall order of this reaction? Anybody have any idea? Raise your hand if you have an idea of what the order is of this reaction. Yeah. You have rate equals K, NO to the second power H2. No, the NO to the second power is telling you, the 2 is telling you the second order. And then you have an H2 there, and there's actually a 1 there, so what's 2 plus 1? 3. So this is a third order reaction. That means that the 3 represents the cube. So when you change the concentration, the rate is going to be cubed. That's going to be the effect on it. It's going to go that, like if you double the concentration, it's going to be 8 times faster. Make sense? So that reaction will be 8 times faster because of these concentration changes. Equation here where you have 2NO plus H2 yields N2O plus H2O. Now they're telling you that the reaction is first order in H2 and second order in NO. Now it's not always going to correspond to the coefficients. The coefficients, you have 2 for the NO and you have 1 for the H2. I just want you to know that the order has to be experimentally determined. It is not associated with the coefficients. So keep that in mind. If it was associated with the coefficients, what would they have not done?
Read this book.
They would not have told you the order here. Is everybody clear? They're telling you the order right here. If the order was associated with the coefficients, they wouldn't have had to tell you the order. They would have just said the order is always associated with the coefficients. And it's not. It just happens to be in this particular situation where you have NO, there's a 2 for the coefficient, and there's a 1 there for the H2. So that's where you see up here the rate constant is associated with K, NO to the second power, and H2. In the book it says, with a rate constant of 2.9 times 10 to the second. The rate constant, it differs for every reaction. So they have to give you that. There's not one in the book. There's not a K somewhere you can go in the book, and it's always the same. That's what makes this a little bit difficult, because up to this point, every constant you've seen has been the same. Like the constant for R, the ideal gas law. A good example. There are other constants as well. What's another constant, Sam? A speed of light. Speed of light's a constant. Yeah. Following reaction is first order in H2 and second order in NO. Does everybody see that?
Yes.
Now, if you pull out this paper from yesterday, right, this paper here, this paper will show you zero order, and they're showing you the units there. All they have to do is give you your concentration in those units, and they're telling you the order. So if you see these units, you're going to be like, oh, that's zero order. And they're going to show you second, negative 1. These are associated with like rates. So if they give you a rate and it has that number, correction, that unit associated with it, then you know that it is zero order. They could give you a rate for an individual concentration. Yes, they can do that. Typically they won't, but they can if they choose to. All right, so just remember that. Remember, this only tells you the total order for the reaction, not the individual order, so I'll take that back. So if they can only give you these units for the total order, not the individual orders. It's important to read. So here it says, remember, you might want to highlight that. Remember, this only tells you the total order for the reaction, not the individual orders. So they can only give you the total order based on the rate. So if you see this unit here, you're going to be like, okay, that is going to be a second order overall rate. So if you see the rate down here and you see a unit associated with it, then they're telling you that's going to be a second order overall. So just like we see up here, when we have a NO2 in the 1, it's going to be third order overall. So the rate should be, they don't show it here, but the rate should be these units here. That's what they're showing, the instantaneous rate. So keep that in mind.
My name was talking to, oh my god, bro. He was talking to Beyonce. Hey, don't you go around it, bad people did. That's what I said. You said our candidate.
How many balls do you have? 3?
2? Oxide into nitrogen dioxide and oxygen, which proceed as follows.
Michaela has the most. Michaela?
How many points do I have?
I don't know. I can tell you who has the most.
So who has the second most? It should be me. So anybody else said I'm right.
Looks like Tamara is second.
That's it, right?
Austin, you're coming in around third.
No way.
Sierra's coming in around third too. Then Vance is in there.
I'm easy third.
All right, who can do the? All enzymes are starts with a P. Raise your hand.
Prevent.
No, they're produced by your DNA. All enzymes are.
Produced by DNA.
What are they? It starts with a P. Raise your hand. Proteins. Very good, Vance.
Inhibitor is a substance that slows down or inhibits reaction rates. Some inhibitors prevent a reaction from happening at all.
Something down would be like alcohol. Alcohol is an inhibitor in that it's kind of like a depressant. Inhibitors slow things down. So if you drink alcohol, it's going to slow you down. That's why we don't want you to drink it and drive, because your reactions slow down. And you can cause an accident and kill people.
Are the results of collision theory in an equation called a rate law. A rate law expresses the relationship between the rate of a chemical reaction and the concentration of reactants. For example, the reaction A to B is a one-step reaction. The rate law for this reaction is expressed as follows.
Okay, is it to the 10th power times 10?
Times 10.
And then is this a negative?
Negative 6, yep. Now they want you to put in the units as well. See if you can cross out the units and get the right units.
Okay.
That's another skill that they want you to be able to
Cross that out.
do. Yep.
So it'll be mole squared times S.
Okay. Now remember, you got to square it here though. So when you square the units, that's going to have effect on them.
So it'll be 3 moles. It'll be 2 moles squared, or it'll be 2 moles and then mole squared. Or do you cross out one of them? So it'll be just mole times S.
Well, get your final answer. I'll tell you what you're trying to do. Okay. S, and then mole liter, or mole. Then we have liter there. Liter times S. Of the units there.
And then
So don't
S
forget
over
when-
here or S at the bottom.
Times S. When you square, you have to square the units.
Transitions to temporary unstable arrangement.
All enzymes are.
Moving.
No. No, it starts with a P. Proteins. All enzymes are proteins. If you remember, your DNA codes for protein. Now, what does the catalyst do? What do the enzymes do there, Jacob, in your body? You're making these proteins, enzymes. Well, catalysts, if you look,
They speed up the process.
they lower the activation energy. Normally, like it would take a lighter to get a fire going, where the catalyst, the enzymes in your body, allow temperatures to be a lot lower. Like you're burning sugar like we burned it in the lab. Remember the lab we did last week, where you caught food on fire? Yeah, the enzymes allow those reactions to occur at lower temperatures. So it's really kind of weird that we live. If it wasn't for enzymes, there would be no life. That's the power behind, you talk about DNA. The DNA, those enzymes, they drive down the activation and allow us to move like this at lower temperatures. Controlled movement, like Michael Jackson type movement. No, I'll check the one from last time tomorrow because that's the most difficult one. We'll give some of those examples on the board. Then we'll move on to oxidation reduction. Apple a day keeps the doctor away.
That's how you smell.
Nice job there, Ethan. Excellent.
Recall that a low activation energy means that more of the collisions between particles will have sufficient energy to overcome the activation energy barrier and bring about a reaction. By lowering the
Got this? Okay. The symbol K? Anybody? Symbol K? Alex? Symbol K? Okay. The symbol K
Sean, you
is the specific rate You got it?
You read it.
Okay.
Is K the same for every reaction?
I got it.
Is K the same for...
You
You got it?
No.
Nah, me neither.
K is not the same for every reaction.
You guys hear that? K
It
is
varies.
the same.
No. Like,
Enough points?
that's kind of
Now, one
a...
day when you're depressed, you're going to want to leave.
It happens.
Yeah, it happens.
Now, C is the speed of light. It's a constant and does not change. So there are constants that don't change. Another example would be R. We talked about the ideal gas law. So can you read for us? Next paragraph.
The symbol K is the specific rate constant. A numerical value that relates the reaction rate at the constant and the concentrations of reactants at a given temperature. The specific rate constant is unique for every reaction and can have a variety of units, including some things with numbers and letters. A rate law must be determined experimentally as illustrated in figure 16.15.
Titans, where are they from?
Spokane, Washington.
Spokane, Washington, shout out.
Shout out.
You ain't never sent me the link. And I just signed twice. I told you go to computerover.com. You're not.
The first time I was sitting right here and I want to get. That's why I didn't look at because she was fucking sad.